I'm going to speak English today. And I'm going to start with a story about my life, perhaps. So I travel a lot. I'm suspended somewhere between Boston and Warsaw and other places. And I also have a 6-year-old daughter. So communicating with her remotely sometimes poses a very major challenge to me because I would like to show her that I'm proud of her, that I'm joyful, sometimes also that I'm sad. And the problem is that it's very insufficient to communicate these complex emotions currently with the systems that we have available, because you have something like that at your disposal, or at best you could have perhaps something like this. And I guess for some emotions it's good enough, but for some others, we need more, right? Because we would like to be telepresent remotely with our most closest people, and then we sometimes feel these limitations. So I essentially work in a field that is trying to handle that somehow, and this field is called emotional computing, or very often also affective computing. You may know it because, for instance, facial recognition systems are very often based on it, but definitely there are more wide and robust applications of affective computing today. One other very relevant thing that is also happening thanks to the development of these systems is that it's easier to compute complex emotions in various spaces, including also not lab spaces, so not places that are specifically designed for conducting experiments. And what I mean by that is, for instance, the major developments in portable devices. Here you can see an EEG headband that can process affective data, actually data from your brain activity, and those brain signals are very important because they're indicative of how you feel, whether you're resting, whether you're relaxed, whether you're smiling, whether you're actively learning something, so they can tell us a lot. And here you see, I'm actually my daughter Alicia's friend trying it on. It's absolutely safe and, absolutely non-invasive also. He was very curious, geeky boy. So I think the fact that we have more portability allows us to kind of scale affective computing to various new domains. Now, in terms of applications of affective computing, it's also quite interesting where we can go. Here you can see a wristband that can actually predict quite accurately seizures and epileptic attacks. By predicting them, it can also save people, and it effectively saves people's lives every day. It's been used for quite a while, also developed at MIT. Another way of handling affective data is, for instance, in your home. Here you can see a project, well, a short exemplification really of a project that we're doing at the Center for Collective Intelligence, where we're trying to compute emotions coming from the sensors to adjust the lighting in your house to your mood. We are also trying to do it in a way that it's more efficient in terms of usage of the lighting, so it's kind of sustainability combined with responsivity towards your mood. And responsivity is actually a very important topic in affective computing because you want to create systems that are going to be responsive to the stimuli that come from your body, that come from your affects, and so on. But it's not all. Actually, we're trying to figure out even a new domain, like a newer level in terms of affective computing, and that's context awareness, which means you're not only responsive to the direct stimuli, but actually you're embracing the whole of the environment around you. And that's something that an AI system of the future perhaps could do. A very interesting example of that is TomNet. You may have heard about it. It's developed by DeepMind currently at a very early test phase. It's a theory of mind network. Now, I'm a philosopher by training, very analytical, so that's a bit of a cheating. But nonetheless, I've known the concept of TOM, theory of mind, for quite a while in philosophy. I never thought it would be implemented in practical life. This is a network that is supposed to have a theory of other mind, which means it's supposed to understand somehow that you have intentions, emotions, while you interact with it. And that's actually very relevant because we don't have such systems yet. We don't have systems that go beyond what you say to understand why you said what you said, how you said what you said, and so on. And here, affective computing combined with language processing can actually give quite robust examples. There are other, let's say, context-aware systems that you may kind of have heard of. This is, for instance, a humanoid robot. This robot is supposed to have a real-life interaction with you. It's actually called Bina 48. As you can see, I'm trying to have a conversation. I'm not sure if she's so eager to have it with me. So that's a problem. But we're also focusing in our work a lot on human-machine interaction and how to facilitate it, how to make it good. And we've discovered that there is this phenomenon, quite known actually in the field, that is called the Uncanny Valley. When you see or detect a system, AI system that is too human-like, you're going to be scared of it. You're going to have this sensation of eeriness. You'll be like, nah, that's not something I want to talk to. And we were trying to check whether that also applies to bots online. So we've created two versions of one system. One was just text-based. The other one was equipped with an avatar that had a voice, could reciprocate your gaze, and so on, could talk to you while also having nonverbal interaction. Actually, both of these systems were very empty in terms of knowledge at the beginning. My students fed it with knowledge, so I'm not sure if it was like super empathetic, what they've taught to my bot. So we had to readjust, but nonetheless, we were trying to see which version of the bot will be more liked by our students. So we used physiological channels for that. We used various sensors that we put on the body to figure out, what kind of affective responses we get. So here you can see some results from the electrodermal activity. Here you see some results for facial myography. So sensors here and here to see whether you smile or frown. And all of these were showing us, that's a heart rate, that people were more engaged when they were talking to the bot that had the avatar and face. But nonetheless, they were not too happy about it. They were engaged, but it was a negative emotion and stress that was kind of released because of the fact that they were interacting with something so uncanny. So it's very important to build the proper context so that you don't get that negative loop. If you're going to build systems in AI that are going to be threatening to humans, you're not going to have it in the best possible way. It's much better to devise something that is easy to categorize. Something like Alexa, for instance. It's a good, I guess, example of non-threatening device, at least at this point, on some level. Now, one more thing that I want to say is that I recently participated in this project in Poland, I am Polish, by the way, about women in technology. And it was a very interesting project because we had to share why we started working in technology, what made us work in this field. And I obviously shared the fact that I'm so passionate about sci-fi movies. But then I had that reflection because they put us in front of these mirrors. It was very, very interesting. And they said, okay, so what do you like about these movies? And I was like, well, I like lots of things, but they're quite negative, most of them, right? So the future is a bit scary. Either for humans or for technology, there's either a conflict or a battle or something like that. So I think it's super relevant today to think about artificial intelligence as a field that has to have ethics and code of conduct. It's very relevant, particularly in our field, affective computing, to handle sensitive data with care of people's privacy, safety, and so on. We cannot be threatening. We have to design systems that are transparent and explainable. And only then we can have a nice, good future with technologies. Thank you.